So, good morning to all of you, dear students. Myself, Apiluddin Ahmed. I am your new mathematics teacher. Here, I am going to discuss chapter 3, which is entitled by matrices. So, basically, here I will discuss the matrix, definition of matrix, and some basic properties of matrices, and some special type of matrices. Yes, sir. So, a matrix. A matrix is a rectangular array of numbers or objects. That means any rectangular arrangement or rectangular array of some object or some special kind of numbers is called a matrix. And the numbers or objects are called the elements of the matrix. Okay, so here we consider one rectangular arrangement. Suppose this is a rectangular arrangement. So here A, B, C, X, Y, Z are the elements of this matrix, and here you see this element A, B, C and X, Y, Z are on the horizontal line, and this line or these elements is called a row elements, or this line A, B, C, this is a row of this matrix. This is called another row of this matrix, and these are A, X, B, Y, C, Z. These are the columns of this matrix. So here you see there are 2 rows and the 3 columns here. 1, 2, 3. These 3 columns here, and this one and this one are the rows of this matrix. Okay. Now, order of a matrix. Suppose we consider a matrix in which the number of rows is n and number of columns is m. Then the order of the matrix we call this one n by m. We write this way, n multiple m, and we read this way, n by m. So suppose a matrix in which suppose 2 rows and 3 columns, then the order of the matrix will be 2 by 3. For here you see in this matrix, here how many rows here? 2 rows. This one is a row, this one is another row, this is a column, this is another column, this is another column. So there are 3 columns and 2 rows. So that means the order of this matrix will be 2 by 3. Okay. Now you see in general we consider here a general matrix of n rows and m columns. So a matrix of the form this one, here you see A11, A12, A13, A1m. That means there are how many elements? Up to m elements here. A21, A22, A23, A2m, like this one. So there are all are the elements of this matrix. And how many rows here? You see 1, 2 up to n. So there are n rows of this matrix, and how many columns here? You see this is a column, this is a column, this is a column. So how many columns here? Up to m columns. So this is a matrix with n rows and m columns. So it is clear that this is a matrix of order n by m. This is a matrix of order n by n. So another thing, you see here we put here A11, A12, A13, A1m, like this one, A21, A22, A23. So behind this there is a logic, or there is a small concept to write this type of form. So here you see this element A11 element, this element contain in first row as well as first column. So that's why we put here A1 that means first row first column. Here you see, suppose this element A23, okay. So here you see this element contain in second row as well as third column. So that's why you put here A of 2, 3. That means this first component 2 will represent the number of rows in which the element is contained, and these 3 represent the number of columns in which this element is contained. Okay, so here you see this A and 3, that means these elements contain the how many in which rows? N rows. That means here is nth rows, and this here is we put here 3, that means this element is contained in third column. Okay, so simply this is a matrix of order n by m, and where these are the elements, and without any counting process we can easily predict the position of the element with the help of this one, this suffix 2, 3 or 2, n m, like this one. Okay, and this matrix in short we write like this one: A of ij n by m. So this is the order of the matrix n by m, that's why you put here n by m, and this I is varies from 1 to up to n, and j is varies from 1 to m. Okay, now you see number of elements of a matrix of order n by m is n into m. That means suppose a matrix contain n rows and m columns, then the number of elements will be n into m. Similarly, if we consider a matrix of order suppose 2 by 4, that means a matrix with 2 rows and 4 columns, then the number of elements will be 2 into 4, that means this will be 8. Okay, now types of matrices. So there are many types of different types of matrices depending their number of rows, column, and their number of elements. So one is a column matrix. So if a matrix having only one columns, then the matrix is called a column matrix simply. Suppose a matrix, here you see we consider this is a matrix, and here only one column is contained here, only one column, this is a column. So then we call this matrix is as a column matrix. Similarly here you see this is only here is a one column, so this is a column matrix simply. Now here how many rows here, you see how many rows here? There are 3 rows, this one, this one and this one. That means what is the order of this matrix? There are 3 rows, 1 column, so that means this will be the order 3 by 1. Similarly here how many rows? This is a rows, this is a rows, this is a rows, this is a rows. That means there are 4 rows and 1 columns. That means the order of this matrix will be 4 by 1. Okay. Similarly we call a matrix as a row matrix. Okay, row matrix. If a matrix having only one rows, then the matrix is called a row matrix. Here you see we put on examples here. In this matrix there is only one rows, that means this is a matrix which is one rows, that means it is a row matrix. Okay, this is another examples of a row matrix, that means you see here only one rows, that means this is a row matrix. Again you see here how many columns here? 1, 2, 3, 4. So this is a matrix of 1 rows and 4 columns. That means the order of this matrix will be 1 by 4, sorry. Now square matrix. Okay, square matrix. Now a matrix in which the number of rows and number of columns are suppose equal, then the matrix is called a square matrix. Here we consider a matrix, examples of square matrix you see here. So in this matrix there are 2 rows, one is this one, another is this one, and also 2 columns you see. This is a column, this is another column. So this is a matrix of 2 rows and 2 columns. That means in this case the number of rows and number of columns are equal. That's why we call this is a square matrix. Okay, so simply you remember this one. If a matrix has number of rows and number of columns are equal, then we call the matrix is a square matrix. Here this is another examples you see here. In this matrix there are 4 rows, and 4 columns. So this is a matrix which is called square matrix. Okay, come to next page. A diagonal matrix. This is another special kind of matrix. This is called diagonal matrix. And before I am going to definition of this diagonal matrix, we'll discuss first what is the diagonal element and non-diagonal elements of a matrix. So you see, suppose we consider a matrix this one, then these elements, that means this one x, y, z, this corner to this corner, these elements is called the diagonal elements, or simply we call this is the diagonal of this matrix or principal diagonal of this matrix. And the other elements, this one or this one, are called the non-diagonal elements. Okay, so now in a square matrix, if all the non-diagonal elements are zeros, that means these non-diagonal elements here, these non-diagonal elements, all the non-diagonals are 0, then the matrix is called a diagonal matrix. That means a square matrix is said to be a diagonal matrix if all the non-diagonal elements are 0. Okay, here we consider some examples of diagonal matrix. You see, this is a matrix. Here all the diagonals elements are 0. Here you see, this is this 0, this here 0, this one, this one, this one. All the non-diagonal elements are 0. So that's why we call this is a diagonal matrix. So here also you see, all the diagonal elements are 0 here. So this is a diagonal matrix. Okay. Now square matrix. Scalar matrix. So a diagonal matrix in which all the diagonal elements are equal is called a scalar matrix. It's called a scalar matrix. Okay, that means in a diagonal matrix in which all the diagonal elements, that means all the elements, this one, these elements are equal, all these elements are equal, then this is called a scalar matrix. So here we take one examples here. This is a matrix and all the diagonal elements here are equal to 2. So that means this is a scalar matrix. Okay, now you see here, a scalar matrix is a diagonal matrix. Okay, a scalar matrix is a diagonal matrix, and it can be also observed that a diagonal matrix is a square matrix. So we can say that every scalar matrix is a square matrix, or every scalar matrix is a diagonal matrix. But every diagonal matrix may not be scalar matrix. or any square matrix may not be a scalar matrix. Okay. So come to another types of matrices. So this is called identity matrix or unit matrix, which is identity or unit matrix. So a diagonal matrix in which all the diagonal elements are equal to 1 is called unit matrix or identity matrix. That means in a matrix in which all the diagonal elements are equal to 1 and the non-diagonal elements are 0 is called a identity matrix. Okay, or we call another way also the a square matrix in which all the diagonal elements are equal to 1 and all the non-diagonal elements are 0 is called a identity matrix. So this is identity matrix, this is another identity matrix. Now what is the order of this matrix? So there are 2 rows, 2 columns, so this is a matrix of 2 by 2, or simply we call this is a identity matrix of order 2, and this is a matrix of order 3 because here you see here this matrix contains 3 rows and 3 columns. So this is identity matrix of order 3. Now null matrix or 0 matrix. Okay, if all the elements of a matrix are 0, then it is called a 0 matrix or null matrix. It is very easy to remember. You see, this is a matrix in which all the elements are equal to 0, so this is a null matrix. Here you see all the elements are 0, so this is a null matrix or 0 matrix. Okay, now formation of a matrix. So this is also important concept for your board exam. Yes, formation of a matrix. Actually they will provide some relation between the elements of a matrix and they will provide the order of a matrix, and from that information we have to construct the matrix. Okay, so if any relation between the elements is given, then we can easily construct a matrix. Okay, so construct a, for example, we consider here, construct a 2 by 3 matrix in which the elements are related by this one. Aij means I plus j. Now what is Aij, or what is the position of this element Aij? The position of this element will be ith row and jth column. That means this element will contain ith rows and jth column. So this is the relation. Aij means I plus j. So from this relation we can easily find the value of, suppose, A11, A12, A13, like this one, because you put here I equal to 1, j equal to 2, then we get A of 1, 2. This will be 1 plus 2, simply 3. So in this way we can find the value of elements. You see here, so here we consider a 2 by 3 matrix because we need a 2 by 3 matrix. Here we consider A11, A12, A13, A21, A22, A23. This is a 2 by 3 matrix, and from this relation, okay, from this relation we will find the value of this one, A11, A12, A13, like this one, voila. We can easily find this one. You see here, A11 means 1 plus 1, this will be 2. A12 means 1 plus 2, this will be 3, like this one. Okay, we can easily find all the values of this one. Here you see A23 means 2 plus 3, this will be 5. Now you put all these values in this equation, in this matrix. Okay, you put here all this value on this matrix, will get this matrix. So this is the required matrix of order 2 by 3 and whose elements are related this relation. Okay, now equality of two matrices. Equality of two matrices is a important concept of a matrices. Okay, now two matrix, when two matrix are called equal, simply if their corresponding elements are equal. If their corresponding elements are equal, then the matrix is called equal matrix. Or simply, if two matrices are equal, then their corresponding elements will be equal. So here you see two matrices are said to be equal if their corresponding elements are equal and they are same order. Okay, suppose they provide two matrices. If this is a matrix, this is another matrix, and suppose these two are equal, this matrix and this matrix are equal, then according to our definition of this equality of two matrices, we can easily find that A equal to X, okay, this X is equal to A, Y equal to B, Z equal to C, T equal to D. Okay, that means from this equation we get this relation. And also you see, suppose they give this relation, X is equal to A, Y equal to B, Z is equal to C, and T equal to D. Suppose they are give this relation, then we can easily verify that these two matrices are equal. Okay, so thank you so much